Thank you. Good afternoon, everyone. I hope everybody had a good lunch. Thank you to the organizers for selecting this paper. I know it was very competitive to get in, so I am glad to be here. My name is Moshe Milevsky. I am affiliated both with the business school, so I'm a professor in the finance area of the business school. I'm also affiliated with the mathematics and statistics department at both of them at York University in Toronto. So I live in both worlds, and you will be seeing that in the presentation today. Although my colleagues in the mathematics department call me a finance professor, and my colleagues in the finance department call me a math professor, so it's a bit challenging. So here's the motivation for what I'm going to be discussing. That has to do with the fact that pension plans, defined benefit pension plans, CPP, or Social Security in the US, takes a bunch of people, puts them together, and in some sense gives them a payout that doesn't depend on their health status. So whether you're male or female, you're healthy or sick, you get to retirement, you're pretty much entitled to the same pension, assuming you've put in the maximum credits. And the question is, what is the transfer there, and is it still going to be a good deal? So that's sort of the overview. So here's an example I'm going to run with for the next half hour. I would like to introduce you to Simon and Heather. They're both 65 years old. They're both about to retire, and they earned the maximum amount of pension credits. So they worked for the maximum possible time they could work. They worked at the maximum salary. They're both entitled to the maximum pension. And the annual maximum pension is $25,000, and it doesn't really care about gender or health. It just says you work the maximum, you get the maximum $25,000. I'm going to set it up so that Simon has a low life expectancy of only 10 years. We know, genetic tests, whatnot, that his life expectancy is 10 years. Heather comes from a long lineage of, long-living Scandinavians or something. Her parents and grandparents and great-grandparents are still alive, so we know that she has a life expectancy of 30 years. Clearly, Simon's getting the poor deal. The question is by how much? So here's one way to quantify it. If you were to buy a term annuity at 3% for Simon, paying $25,000 a year, that would cost $212,000. There's no mortality here. I'm simply buying a 10-year term annuity at 3%, it's $212,000. If I buy a 30-year annuity for Heather, it's going to cost $487,000. If the system is fully funded, and there's a big asterisk there because very few are, the system should have $700,000 set aside to be able to pay Simon's annuity and Heather's annuity. Of course, Simon's annuity only costs $212,000. He's contributed $350,000 to the system. Heather's annuity costs $487,000. She's only contributed $350,000 to the system. So when they both sign up for their Social Security benefits, Simon hands over to Heather the sum of $137,000, and Heather says to Simon, "Thank you very much for the transfer of $137,000." This is about 30% of the value of his pension entitlement. So the question is, why does Simon want to be part of a deal where, in a sense, he is transferring to Heather this amount of $137,000? And the answer, as most economists would say, is that when you have an annuity, whether you buy one or in a defined benefit pension plan, you have valuable longevity insurance, and that provides utility benefits. And this is sort of the main picture for the paper. Simon's remaining lifetime, Simon has a random remaining lifetime, and he may be expected to live to the age of 78, but Simon has much more uncertainty in terms of how long he's going to live than Heather does. Even though Heather's going to be living much longer in expectation, the volatility of her longevity is actually less than the volatility of his longevity. His is going to be about 62%, hers is about 33%. So he values the fact that he is, in a sense, pooling risk between Simon and Heather. He's pooling risk, and he gets some sort of utility benefit, and that's why he'd be willing to participate in this sort of a scheme, because there is a small chance that he ends up living longer than she does, and the actual transfer is in reverse. X ex post. So here's the research question for today. Do the welfare benefits for Simon outweigh the wealth transfers to Heather, or are the Simons of the world simply better off not annuitizing? At what point is Simon's health so bad that when he gets to retirement he says, I'm not interested in being part of a pool with people that are healthier than me. What I want to do is I want to spend down my wealth myself. I'm not interested in annuities. And where's that cutoff going to be? Now, this is a question that has a long literature. In fact, Peter Diamond, in his presidential address to the American Economics Association, made the following comment. He said that uniform annuitization, i.e. everybody pays the same price and gets the same income, would favor those with longer expected lives, such as high earners, but Brown, that's Jeff Brown, shows that there's much less diversity in the utility value of annuitization than previous comparisons. For those of you that are familiar with this literature, what Jeff Brown did, is he said, look, even if you have very bad mortality and you pool it with someone that has very good mortality, the transfer isn't that great and you're still willing to be part of that pool. Of course, the gap in life expectancy that he worked with was about 3 to 5 years. Nowadays, the gap is much larger, and the question is, at what point does this gap no longer hold? How large is the mortality heterogeneity gap before a pooling benefit is destroyed? So this brings me then to the year 2018, and this is some research that came out of Chetty et al., very widely cited even in the last couple of years, which shows mortality rates across income percentiles. So here's how to read this. If you are a 60-year-old male in the lowest income percentile in the U.S., your mortality rate at the age of 60 is 22 out of 1,000. On the other hand, if you are in the highest income percentile in the U.S., your mortality rate is 2.8 out of 1,000. 22 versus 2.8. For females, the gap isn't as large. I'll get to that a little bit later. So this mortality income gradient, as it's called, is actually getting wider over time. And between this and some of the genetic tests that are being done, we can really do a very, very good job of telling someone what their life expectancy is and what the standard deviation is. And at some point, that gap's going to be big enough at which people are going to say, I'm not interested in being part of the pool. I'm not benefiting from the longevity insurance. So that's really the issue. So what I have to do in the 25 minutes that I have left is a little bit of economics. How do you value the utility and welfare gains of pooling? I have to do a bit of actuarial work to model the mortality, and finally some sort of insurance pricing so that we can get how this works. Now what I'm going to do, I like the term, somebody said earlier to do the dessert before the main meal. I think Andrew said, yeah, I like that. So I'm going to say the same thing here. I'm going to preview the main result, and then even if I don't get to finish, at least you saw what this was all about. So here's how to read this chart. This is somebody that has a life expectancy of 70. He's at retirement, not going to live very long, and we know, and I'll convince you later, that he has a very, very high volatility of longevity. Life expectancy is 70, but there's a lot of uncertainty there. This is somebody right over here with a life expectancy of 100, healthy Heather, and she has a very, very low individual volatility of longevity. And what I'm plotting here on the y-axis is the fraction of retirement wealth that they'd be willing to go up to buy an annuity. It's basic welfare analysis. It's called annuity equivalent wealth. If you did not have an annuity, how much money would I have to give you to make you as happy, utility-wise, as somebody that has the annuity? So let's plot this. Let's take somebody that is very, very low life expectancy and very, very high life expectancy, and let's put them in a pool that's fair. They're swimming with people like themselves, and this is what the picture looks like. Here's how to interpret this. If you have a very, very high volatility of longevity, life expectancy of 70, then depending on your relative risk aversion, you're willing to give up between 75 and 120%, meaning it is worth to you that amount of your wealth. As you make this person have a higher and higher life expectancy and a lower volatility of longevity, they simply don't value the insurance as much. They say, well, you know, there's very, very little uncertainty there. I'm not really benefiting from it. Now, of course, this is going to depend on your coefficient of relative risk aversion, and I'm going to talk a little bit about it later. I know Glenn's going to give me a tough time about using a CEAR-RSI model. We can extend it, but the point is that this is what this picture looks like when everybody is swimming with people like themselves. Now let's see what happens when we take all these people and we throw them into the same pool together, which means that they're all paying the exact same price for their annuity. And what happens to this picture is that it's completely reversed. You see, what happens here is that this person who expects to live to the age of 100 and has a low volatility of longevity says, look, I wasn't really interested in buying an annuity. There wasn't a lot of uncertainty there, but boy, if I get to swim with people that have a low life expectancy, I'd love to do that. I'm going to be buying a very, very cheap, underpriced annuity because I'm pricing it as if I'm 82 when in fact I'm living to 100. So I want to swim. I want to swim in that pool. Vice versa in the other direction, when you take somebody that has a very low life expectancy and a high volatility of longevity, they love the idea of longevity insurance, but now what you're doing is you're selling them a very biased loaded annuity in the sense that what's happening here is that they have to pay much more than the expected present value of the benefits, and they say not really interested. And in fact, this mark over here where it hits the red line is when it's 0, when this person says, you know what, just not interested in buying the annuity at all. If I have relatively low level of risk aversion, I'd rather self-annuitize or just self-insure and just take the money out myself. So the question, the empirical question is, and I'm going to get to the data in a moment, is in reality, in the year 2018, given data that we have now about mortality heterogeneity, have we reached this point? Has this been breached, where people that have a very, very low life expectancy and a high volatility of longevity are paying so much for their annuities that they say, sorry, I'm just not interested in it, I would rather do it myself, or are we still above that? That's sort of the research question, and the main result is, empirically I'll show you that we're well above that line so far right now. It's unclear what that's going to look like going forward. So how does one model the annuity equivalent wealth? So I apologize, a bit of the math here. This is how to read this. If we have a constant mortality hazard rate, constant, everybody dies at the absolute same rate, the utility that you get from not annuitizing is going to be U star. If you annuitize and you decide to buy an annuity with all of it, then your utility is U star star. And you can actually write down some nice expressions for this when mortality hazard rate is constant. And the quantity that we're solving for is this delta right over here. That was the y-axis in the picture I showed you. I'm looking, how much money do I have to give someone? How much additional wealth do I have to give someone who is not buying the annuity to give them the same amount of utility as someone who decides to buy the annuity? This all started with the work of CEAR-IRE, Moshe A, where he came up with the life cycle model with annuities. And this metric, I think Larry Kotlikov used in the 1970s to take a look at family pooling. But this is sort of a well-defined metric in the pension annuity field. And the question is, what is delta? And the research seems to suggest, or at least the literature, that this delta is positive and quite positive, even if you're buying loaded annuities, even if you're swimming with people that are much healthier than you. In fact, it's actually quite nice that when mortality rates are constant, and you actually solve this utility model, and you try to equate this with that, and then you invert and you try to solve for delta, you can actually write down an explicit expression for delta, the value of pooling. How much do you benefit by buying some sort of annuity or by being in a pool with people that are annuitized? It's going to be this expression here, interest rates, mortality rate, coefficient of relative risk aversion. So for example, if the coefficient of relative risk aversion is 2, and we're in an interest rate of 3%, and let's say you have a life expectancy of 25 years, hazard rate 1 over 25, then the value of pooling is 96%. The AEW is 1.96, and that's sort of consistent with some of the earlier estimates out there for the substantial value that comes from annuities. Interestingly enough, if you let gamma go to 1, so you have a logarithmic utility, and you assume that your interest rate is equal to the ratio of these two variables, you get this cute expression, at least I think it's cute, that delta, the value of longevity pooling, is square root E minus 1, which is about 64.9%. So this is an actuarial interpretation of Euler's constant. And that is that square root E minus 1 is the value of longevity pooling. So if anybody ever asks you at a cocktail party, what's the value of longevity pooling, and you can't remember any number, you just say square root E, because that happens to be what happens with logarithmic utility. All right, so now let's get back to real live mortality. Obviously, mortality rates are not constant. There are two things here that are interesting to note. This is the same table I showed you earlier from the Chetty data. Number one, obviously mortality rates are not constant with age. They increase exponentially. Number two, and this is sort of at the heart of what I'm going to be discussing, if you take a look at the gap between the lowest income percentile and the highest income percentile, it is roughly shrinking. So what does that mean? The really, really unhealthy relative to the healthy is a multiple of 10 to 1. Let's ignore this one, not convenient. Here it's 8 to 1. Here it's 14, 10, 5 to 8. What seems to be happening is that the multiple is shrinking. So relatively speaking, if you're a 60-year-old that is unhealthy or lowest income percentile, the multiple is only about 5.8 versus 7.9. So the dispersion between high and low income shrinks over time, and as well this grows exponentially. So this is where I get a little bit into the actuarial theory. This is consistent with something called the compensation law of mortality. I'm going to abbreviate that CLAM. The compensation law of mortality from the biodemographics literature. What does the compensation law of mortality say? It says as follows. When you have a heterogeneous group within a particular species, healthy members with low death rates tend to age faster than people that have higher death rates. So what that then means, and not only that, these converge. And at some point they converge to a constant, somewhere around 100, and then it becomes constant from there. This is known as a mortality plateau. So if you are lucky enough to get to the age of 100 and something, you stop aging. Not only do you stop aging, apparently it's the same for males and females, and it's around 50-50. And, you know, it's controversial. There's not enough centenarians around there to be able to say this with precision. But this is known as the compensation law of mortality. The key takeaway from an economic point of view is that right here, if you have a very, very low mortality rate, young, healthy female, you're aging very, very quickly. That slope is higher than if you're in this group right over here, you're aging more slowly. So, for example, this is someone with a very low income percentile. Low income percentile, very high mortality rate, but they're not aging as fast. This is someone in the highest income percentile, the wealthiest 1%, very low mortality rates, but they're aging faster. Aging faster is a sign that your initial mortality rate is lower, and then these things converge. What's the economic takeaway here? Somebody that has a very, very high mortality rate, they're aging slowly. The inverse of that is the uncertainty around their lifespan. They have a higher volatility of longevity. Somebody that has a low mortality rate, they're aging very, very fast. There's very little uncertainty. The standard deviation is going to be smaller. So what happens is that when we pool people with this group and people with this group says, you know what, I have a low mortality rate, I'm not interested in longevity insurance, and I'm aging very fast, I don't need the longevity insurance. But when you mix them with people in this group, they say, I'm getting a subsidized value. Vice versa in the other direction, the people in this group say, I have a high mortality rate, I have a lot of longevity uncertainty, I value it, I'm willing to be pooled with these people as well. You need to remember it, CLAM is the abbreviation. Apparently they're the longest lived organisms, but even that is controversial. So within a Gompertz framework in which log biological hazard rates increase linearly with age, here's how to think about this. Your mortality rate at any given age is going to be equal to a constant accidental death plus this amount that's growing exponentially. H is the initial H0 hazard rate, G is the growth rate, and here are the two important takeaways from this slide. The standard deviation of your remaining lifetime increases and is proportional to 1 over the growth rate. So if you have a very, very low mortality rate, you're aging very quickly, you have low uncertainty of volatility. Vice versa, if you're aging at a very, very low rate, this number is going to be much higher, so this is going to be the rationale for having that insurance. To get a vision for what this looks like over the life cycle, let's take Simon. And let's take Heather. Simon, remember, had a life expectancy of about 78 years, and Heather has a life expectancy of 98 years. What does the volatility of their longevity look like? When they're relatively young, it's somewhere around 20-25%. His volatility of longevity is higher, but then when you get to very, very advanced ages, it converges to 1, partially because of the plateau as well. All right, so what does all of this mean? This means that there's a link between the slope and the intercept in these Gompertz regressions, which most of these papers do. I mean, Chetty et al. Is a good example of it. If you take a look at their data, their mortality data is presented in terms of slope and intercept for their Gompertz regressions. You have 100 values for male and 100 values for female. You can actually plot them, and you get the following picture. So here's how to interpret this. They have 100 Gompertz slopes for male and female, and what you find is that people that have a very, very high mortality rate, you know, the poorest have a high mortality rate, they are aging very, very slowly. So you have a Gompertz mortality growth rate that's relatively low. It's about, you know, 5.5, 6%. Then you take the wealthy individuals right over here. They have a very low mortality rate, but they're actually aging very quickly. Traditionally, we think of mortality growth as being somewhere around 8%, the Gompertz law of mortality. We double every 10 years, but there is definitely dispersion there, and there is this negative link between the initial log mortality rate and this growth rate. In fact, if we extend that line, this is where the data is obviously, but if we extend that line and we go all the way to G of 0, obviously we don't have any data that way, but that is exactly where the mortality plateau is. So if somebody were to ask me, at what age does mortality plateau, I would take these 100 coefficients, line them up and say, oh, somewhere around this point here, and that'll give you an estimate for where it is, and you can actually run this regression and get that. So using just the Chetty numbers, and I'm going to do this soon for Canadian data in a moment, if you actually run a regression, you say, okay, there's this negative relationship between the initial mortality and the mortality growth rate. Where is that intercept where that thing is going to stop increasing? For males, it's going to be at the age of 100. For females, it's going to be roughly at the age of 95. If we throw out the lowest 10, where we have abnormally high mortality rates, and you just do it on the 90 data point, so you take 90 Gompertz coefficients and you run the regression. The interesting one is that males is at about 110, females is at about 110. They both reach that plateau, and this is going to be the plateau amount. So we have a range. We have the people that are aging very, very quickly. They age at about 10% a year. They're aging slowly at about 7% a year. And that's sort of what these regressions look like. And this is actually consistent with some data. This was an article, I believe, in Science magazine that looked at Italian data on where plateaus are using biological data, and they found numbers around 110. So this 110 plateau. There was an article, or an NBR paper by Kevin Milligan, and they did the same thing for CPP data here in Canada. So they extracted Gompertz parameters. They didn't report it in the paper, but Kevin was very, very nice to send me the original code, and we were able to actually recreate those Gompertz coefficients. And you get a similar picture as well. So this is in Canada. This is people with the highest income based on the CPP data. Their initial mortality rate is going to be much, much lower, but they age quickly. On the other hand, you have people that have very, very high mortality rates. They're going to age more slowly. There's something quite odd about their female data, in that this slope is quite low, and you see it when you actually run the regression. Their male converges at the age of 100, 97, that makes sense, but for females we get about 63 is the point of convergence. What their data is saying is that mortality for Canadian females plateaus at 63, they stop aging, which, you know, makes absolutely no sense, but that's what's coming out of these coefficients. So something is odd on those coefficients, but the bottom line is, what's the takeaway for people that have suffered through this for 10 minutes? There is a negative slope between the initial mortality rate and the mortality growth rate, number one. Number two, what that means is that this person here faces a lot more uncertainty about how long they're going to live, relatively speaking, than this person over here, where the uncertainty is less. Final point, this person values the insurance a lot more, and that's really the key takeaway. So a bit of history for those of you that are wondering, gee, does that line work not just within groups at the same point in time? Does it work over time? It actually does. I just ran this recently. It's not in the paper. So I looked at cohorts in Canada from 1910 to 1960. So that would be age 35 to 70 in the health and mortality database. And you kind of see the same pattern. Early cohorts obviously didn't live as long. Their mortality rates were higher, but their mortality growth rate was lower. And then we have the later cohorts. They're living longer. Their initial mortality rate is lower, but they're aging at a faster rate. So this seems to be consistent historically, not just within the same group. So now let's get back to pensions and pension annuities, since I have less than 10 minutes left. So let's say we want to price and value annuities on this compensating law of mortality line. So, you can price this using the Gompertz-Makeham law, and here's how to interpret what's going on here. So let's take somebody that has, relatively poor, relatively low income. Their mortality growth rate is quite low, but they started off from a very, very high mortality rate. Their initial age 65 mortality rate was 3.7% relative to their wealthier cohorts that had 0.5%. Their life expectancy is only 14 years versus the life expectancy of 24 years. There's a 10-year gap, but the key here is that the annuity factor is going to be $10 for this person and $16 for this person. This is the fair price that they're willing to pay. If you pool them with people in the same group, this is what they all should be paying for this benefit. If I did not put them on the CLAM line, or the compensating law of mortality line, then I wouldn't have a different mortality growth rate for different groups. I would simply say, well, ln H is different because one is healthier and one is less healthy, but we're going to have the same mortality growth rate. So this is obviously going to make a difference. If you write down the expression for annuity equivalent wealth under a more general mortality model, you end up with this expression here. Let me try to give you some intuition for this. So this is the annuity equivalent wealth, or the value of longevity risk pooling. What you see on the right-hand side is an annuity factor to the power of 1 over 1 minus the coefficient of relative risk aversion. You scale the initial mortality rate by that. There's obviously going to be an interest rate embedded in this, but this is really all you need to go to the data. So the final stage is to actually go to any mortality table data or any demographic data to extract the H and the G's using the Gompertz regressions, to take a look at the population H and G's and see, do I want to swim with it or not? So I would come to this formula by saying, look, my H is, 1 in a million. My G is I'm aging at 8%. You're forcing me to swim in a pool where the average age H is 7 in a million and the average mortality growth rate is 9%. Am I willing to swim? And when we run this, and if the delta ends up being greater than 0, I say, all right, I'm not happy, but I'm still gaining utility-wise. If I run this and I get a delta that's negative, I say, sorry, I'm not interested in swimming in that particular group with that particular pool. So here's a hypothetical example before I show you the actual data. So let's take somebody with a mortality growth rate of 5.5. That immediately says they're aging very slowly, their initial mortality rate was very high, low income. This individual, if you offered them a fair annuity, they'd be willing to pay 63%. Yes, that's worth 63% to me. You put them in a group annuity where you mix all these people together, then they say, well, I'm not happy, you're charging me a little bit too much, 24, but if you pool them, if you take a look at someone with you're pooling them with sharks, these are people that are obviously healthier than you, I say, hey, that's 5.9%, very, very close to the level of 0. For example, if we take a look at this group here, I have mortality growth rate of 10%, and I'm in a pool together, and we take someone that is, fair mortality, meaning that it's fairly priced. I'm willing to pay it's worth 27.2% for me, but once you mix it and you say, wait a minute, we're going to put you in a group, it's not going to be worthwhile. So now let's go to the final data set, and I'll be done. So here's how to interpret this. Let's take a look at the Chetty data. We have low income. Their initial Gompertz parameter was 1.6%. Their mortality growth rate was 5.9. And what this says is that if you were to put me in a pool like with like, my annuity equivalent wealth would be 62% higher. If you put me in a group, then I say, well, I'm subsidizing other people, but I'm still willing, it's still going to be positive for me. If you go all the way down, the pattern that you're seeing here is as follows. Low income to very high income. What you immediately see is that your H, your intercept, is going to get lower. This person's mortality rate is much lower. The G, the growth rate, is going to be the exact opposite. You're aging more quickly. The volatility of longevity, I mentioned this earlier. The healthier you are, the smaller it's going to be. The less healthy, the higher it's going to be. What's the fair annuity? If you were buying a fair annuity, what would it cost? Obviously you have to pay more because of the fact that this is going to be amortized over a longer period of time, but the key column is this one right over here. If you are in a low income and you're pooled with other people like yourself, you're willing to pay quite a lot for longevity insurance. On the other hand, if you're high income, you say, you know what, I just don't value this very much because the volatility of longevity isn't that great. I don't value it as much. Now let's throw you into a pool with other people and you're part of a group pool. Now this person right over here says, you know what, sign me up. I was only interested in it to the tune of 30, now it's 46 because now I'm getting this subsidized annuity. And the reason that these two numbers are the same is because by definition, if you have somebody in the 50th percentile getting a price that's in the 50th percentile, the numbers should be the same. That's what this looks like for females. For males, it's going to actually be slightly more extreme. What this means is that at the low income level, the fair annuity is valued even more for someone. That's partially to do with the fact of their higher mortality rate and higher volatility. Same pattern that you saw before. You have at the 50th percentile is going to be exactly the same. And at the bottom you get the reversal. So somebody that's very, very wealthy says, you know what, not terribly excited about the annuity, but when you give me this fair price, you know, overly fair or subsidized pricing, I'm willing to take it. So I'm done. This is my last slide. So what did we learn in the last half hour? Well, hopefully mortality modeling can be cool. Mandatory pension annuity pooling results in an expected subsidy. It's a transfer from low income to high income. We knew that. Is the utility insurance benefit worth it? Well, we can take mortality data to a utility model and check. We also learned about something called the compensation law of mortality, which links low mortality rates with high mortality growth. Another way to remember this is that rich women age fast. Utility gains are still there in 2018. Why? Because per this compensation law of mortality, low income group have a higher volatility of longevity and value pooling more. If I could summarize this entire paper with one bullet point, it would be this one right over here. The utility gains are still there. Even though you're mixing me with people that are going to be living much longer, it's because of the uncertainty is so great for low-income groups. The higher volatility of longevity makes you value pooling the most. There's an analytic expression that you can use to easily test if the value of pooling is positive. That might be of interest to actuarial economists. The situation is going to be much, much more complicated when exogenous income and pre-existing annuity wealth is included, because you now are looking at this incrementally and saying, do I really need more annuity and pension income? And finally, with pre-existing pension income, Simon may not want any more annuities. This ties into the current discussion about whether people should be annuitizing their 401k and IRAs and 403bs, and we're encouraging them to go out and buy an annuity because annuity provides longevity insurance. But remember, many of them already have annuity income in the form of Social Security, and it's unclear, especially if you're in poor health, that you want to pay 30% more than you have to buy an annuity when, yes, longevity pooling is valuable to you, but you already have pre-existing annuity income. And that's it, ladies and gentlemen, so thank you very much.
I'm a economist masquerading as a finance professor since I'm wearing a suit. I did not put on a tie. But I'm actually suffering a little bit the same issues of being cross-appointed between two departments, in this case economics and statistical and actuarial science. And all the economists are telling me that, well, you know, I don't know if they're saying it's too much stat, but not really. But the statisticians are going like, oh man, you do economics, that must be hard, right? I should also start by thanking Philippe for inviting me here. It's a pleasure to be back in Montreal. I was here until 2012 and I enjoyed it very much. And a little bit of snow on the ground is no challenge here. And then I don't want to insult the other people who are discussants here, but I can, you know, given that I'm now here as a discussant, clearly means that there's a much less competition on discussing papers than on actually paper submissions. They will not have chosen me. So let's get on with this. I'll be quick. We can get back on track and see if we can make this work. So let me start by saying this is a super interesting paper. I read it twice. Once because I read it a long time ago to kind of get prepared for what I was actually doing. And it's written a little bit like a crime novel, if you can. It's not a good expression, but you know, it's kind of like a crime novel. And I mean, who's the killer, right? Where is the killer? And then it has interesting people, like, and people that you like. Like, think about poor Simon here. He's been hard working all his life. Now he's 65. He just want to spend some time, tired. He's just, and then he dies.
You actually don't get out very much, do
you? Well, I can go with the economist, and they're too busy working, so I go back to the stats people and then go to the right club with them. But anyways, that's getting away from the real topic. So I know we're being filmed and everything, so since there are a bunch of Danes here, in Denmark there's this, what's the definition of a widow? It's a woman who lived so long that her husband died of it. Moving on very, very quickly.
That's an actuary question, isn't it?
So reading the paper and just starting out at the abstract, you read the first paragraph and it's you could think about what's the main question here: who values life annuities more? Is it the healthy retiree who expects to live long, or is it the unhealthy person? And the really cool thing here is that where you would initially say that economic wisdom would assume high mortality rates lead to an increase in the subjective value of annuities. This is not really what this paper is about, because you bring in here, instead of these expectations, you bring in uncertainty. And I do a lot of work on option pricing, and uncertainty is great to have, and it really turns upside down on its head, this whole thing about expectation and uncertainty, and you do a nice job in presenting that and saying you have this type of situation where instead of having higher expectation about something, you now also, and you would expect higher volatility, you now have higher expectation and lower volatility. And it creates a kind of, if you think about this in terms of assets, and an interesting asset that has this flipped relationship between uncertainty and expected value. So the main question is, do you want to swim or not swim with sharks? You could also ask, so how are sharks wealthy, and if they are, where do they actually get the money from? No, I'm kidding. Seriously, what am I seeing this? I mean, the way I understand it is, when is enough pooling enough? In the sense that when you no longer benefit from pooling, you phrased it as, is there benefit from pooling? I guess what I'm thinking, well, now I know that this person here is actually Simon, so I'm glad I mentioned him at the second slide, that he's the guy who might not want to pool, but that's, and I'm going to come back to that. I think that's because he's pooling too much, right? I mean, he would clearly want to pool with his own fish, or his whatever we should put in his own group, right? So I guess in terms of policy implications, I mean, how many people should you pool together for this? And it's a very interesting contribution to that. And it's also darn cool data, right? I mean, this stuff that goes on with this data and these relationships and whatever you have, and then you spread it up on income. So what is being done here? I'm not going to put up any equations and not going to try and explain anything. But what's really neat here is that it's driven by data and minimum assumptions about models. And then you derive these expressions for the value of the pooling. Some spelling mistakes, sorry about that. In terms of fairly priced annuities, and then there's some nice intuitive relationships here. So that's an increasing function of the hazard rate, and then it's linked to this individual volatility of longevity, and it's an increasing function of that. So that's all super cool. And again, you have the data, and you can get it to the data, and there's assumptions are validated by the data, because it's very much driven by the data that you have at hand. So And this is maybe where, so I guess the starting point is that you have these social security programs. And then the question is, so are they still of value? It's not whether or not we should start them, because they're already there, right? So that's the premise we're working under. And then the question is, is there value of that? And clearly it differs between rich and poor, or males and females. And again, Simon here is potentially coming to the point that if he changes a little bit his risk preferences and so on, he might not even be interested in participating with this anymore. So my first takeaway is I better get rich soon. Right? I want to move up to that 99th percentile. And this counterintuitive relationship between risk and returns, interesting problems. And then of course, poor males, right? I mean, damn, that's a big. I guess in terms of explaining this to people, they're being treated so unjustly. So I mean, as policymakers or whatever the implications of these things are, you need to. If somebody ever gets wind of this, you gotta start preparing to explain to these people why they're actually contributing to this thing. They're clearly being ripped off again. Not because their wife lived so long that they died of it, but it's just loaded completely against them. Okay, so low income males, they would benefit from pooling. They would probably, again, rather pool with their own subgroup. So then that's this thing about when is enough pooling enough. And from the way I see it, I think it's actually more interesting where these lines start crossing than whether or not you should pool together with anybody else, right? Because it seems that it has huge implications for when you should actually allow people to not pool or to pool amongst themselves only. So, so here I should have waving my red flag now as coming from a social welfare country. Well, I mean, Danish and everything, we subsidize everything. And how can we then justify these subsidies? Okay, so the question is, what needs to change to make this reasonable? So again, everything is driven by data, and everything seems cool, and I mean, it's completely trustworthy and everything. It's super nicely done. So why? What I mean, is there anything lacking? You talked a little bit about suppose there was some previous income and some annuities and stuff like that. What if we think about how can we make this good? If we start comparing your equation 7 and 8, so 7 is the one that says if I'm pooling amongst my own species or whatever we should call them, and 8 is if I think that's the way it is, if I pool among with sharks also. So if I'm trying to justify to Simon why he's participating in this, how am I gonna, what should I do? Can I make more transfers from rich to poor in a way that makes this, okay for him? Do I need to change how I pay out money? Is there a way of adapting these things? So I guess what I'm trying to think about is if, from my point of view, I think it would be interesting to know those lines that are so clearly in, I don't know if you remember the plot where they started up all the way over here, and this was for the poor guys who would value pooling individually amongst themselves quite a bit. And then if they were pooling with everybody else, it started down here. There must be some in-between. Question is, how do we arrive at that in-between where people are kind of, indifferent between who they pool with, but still interested in pooling. And then, are there benefits that we're not accounting for, and which factors beyond H and G, and I got confused because there's H and G, but there's also an M and B, and they're linked, but they're not necessarily the same, and I think in one table there's a reference to the M's and the B's, but it's actually the H and the G's that are in the table. But that's just a minor thing. So what else? I mean, you have an interest rate, there's a subjective discount rate, there's some risk aversion. If I'm a poor guy pooling with the rich women, besides having some great parties, what else am I getting out of that, right? I mean, is it really, it's not that you're not completely honest about these things are the same, they're assumed to be the same throughout, but is it a matter of, do we need to make an argument that you are actually getting better rates or a better deal by pooling with the sharks also? Maybe that's a way of justifying why Simon should still go and swim with the sharks. So in Denmark, if you're rich, if you have a lot of wealth, I think that's still the way it is. By now, I think I've been away from Denmark so long that I probably won't qualify for any kind of pension if I ever go back.
They'll subsidize you anyway.
They will in one way or another. So there's a penalty for wealth when you enter into, like for the public pension plans, right? So can we really, when we look at these things and $25,000, can we really compare these sharks and the regular fish, right? I mean, the analysis we're comparing with, and the willingness to how much would they pay for $1, and they're 68 or 35%, and they're happy about that. I guess that's also related to the bigger picture analysis, where you start them off with different wealth and different annuities already, and how do we compare these people, right? And I guess at the end, if the starting point is that there is this pension plan and it's mandatory, then you could be nasty and say, well, does it matter because you have to participate in it, right? So do we need to solve this, and do we need to justify for Simon, or are we just going to keep him in the dark and tell him that there's nothing in it? Okay, 1 minute and 40. I had no idea that I could speak for 15 minutes about something like this, but I've been proven wrong. So just a quick question. So the income, and I mean it's beautiful, right? There's this relationship between income and longevity. So could we think about that is that proxying for something else? I started writing something about, well, if I'm healthy, I earn more because I've had more, whatever. Where do I put something about? Yeah, so if you think about it from an asset pricing type of perspective, where you do all these sorts and different risk factors and whatever, I would be very interested in seeing if there is some way of, if it's really just an income thing, or if it's income proxy. You mentioned this yourself, the tall Scandinavians. Is it just height or something else, or something silly, right? I'm thinking kind of like double sorts along these lines or whatever, so that I can see, or things like, it could be that it would be even more interesting if we had these not sorted on income, but something else completely crazy, right? And we would get even more or better explanation. I have no idea about this, but it was something that I was thinking about when I read, because there is this income, and it's a nice. There's clearly some relation there, but what is it a proxy for? Okay, and then just some questions about what does things like parameter uncertainty, is there a way of saying that there is uncertainty about these things, and it might actually be that Simon would be much better at it? And in the last 3 seconds, I'm just going to say nothing. It's a great paper.
Thank you. So, Moshe, do you want to respond and take questions from the audience?
Thank the discussant for the comments. I'll be delighted to take questions.
Yeah. Once you take the contributions into account, do you get the subsidy reversed in the sense that the wealthier high-income households will pitch in a constant fraction of their highest salary, but the benefits are capped? In other words, what I have in mind is you're looking at the benefits only, but I can, as Lars was saying, I can reverse some of that by changing the contributions themselves. And in a way, what would I need to do on the contributions in order to maintain it fairly actuarially fair and observable market?
Oh, probably very controversial to say males that they only have to contribute half of CPP, and females should double their CPP contribution.
Maybe not gender, but income could be one that is. We already have progressive tax schedules.
There's certainly fixes. I'm not sure that this is about fixing the pension system. That's beyond my pay grade. the pension system, it is what it is. What I'm addressing is that there's this movement to get people to take their savings. Annuity companies are doing this. Buy an annuity when you retire. Take your 401k, annuitize. Take your 403b, annuitize. Why? Because you get lifetime income and it's longevity insured and so on. And what I'm saying is, well, you know, it's unclear that people want more of that, especially if we have Simons and Heathers together. I think that's sort of the main point, as opposed to fixing the problem in the pensions. If anything, the pension systems are going even further in that direction, in that you know, you can't use gender for almost anything in many European countries for insurance pricing. Car insurance, life insurance is starting. So, but I certainly agree with you that you know, if you allowed people along the way with higher mortality rates to contribute less, you could fix this problem. But I'm just not sure I would advocate that. I don't know if I'm answering your question at all. I agree with your comment, is what I'm going to say. Yeah. Glenn.
Yeah, one reason I was very excited by this is we've been spending a lot of time collecting information on subjective perception of longevity risk, using fully incentivized scoring rules, none of this hypothetical stuff, but actually critically getting a sense of people's confidence in their longevity risk, not just how long will you live, but the confidence that they hold. And what's really exciting about this is that correctly you did the case where let's plug in some quote-unquote reliable objective numbers and assume that people know those numbers. What would the calculations be? One of the fascinating calculations would seem to me would be to examine what if you plug in people's subjective perceptions of these, which take the same form, they're not, and there's massive deviations from what you expect. There is, for example, very little bias with respect to gender differences, but there's massive bias with respect to the absolute length of longevity risk. There is tremendous overconfidence, and I'm using that in the correct sense of over-precision. None of this, you know, over-placement nonsense. It's over-precision. So the real question is, maybe that's why a lot of people participate in this, because they have, you know, this is a hypothesis. The reason that people participate in this is that they have radically false longevity, subjective longevity expectations. And I should quickly add, as you well know, so do many actuaries historically. So this is a very, very difficult problem with competing risks changing over time. The one thing we have not done yet, it's planned for retirement purposes, is to look at this over the life cycle. We've started doing this a little bit. But I think that to me is a very exciting issue, is to plug in, not change everything. I mean, that's just one thing I would change because it's a relatively easy thing, and then just see under those circumstances would people continue to participate.
I guess if Simon's slightly overconfident, he might be willing to participate in this.
Yeah, so you could ask the question, take the distribution, what's the level of overconfidence that Simon would need? That's a well-defined calculation, such that, or what's the bias, but let's just focus on overconfidence, as that's the overriding behavioral factor we're seeing. So.
Yeah. Any other questions or comments?
All right, well, thank you very much.